Good morning everyone, and welcome to part 2 of the little mini worked exam answer series that I first posted yesterday, or the first part of which I posted yesterday. So we're carrying on with our amount of substance question today, and we're moving on to part B of this question, which is asking us to do a different calculation, use different skills from what we did in part A in yesterday's video. In part B, we are preparing zinc chloride, and we are going to be trying to find out the mass of zinc chloride that can be made in this particular reaction. So we've got zinc chloride, and we're told that we're making the zinc chloride in the lab by the reaction of zinc oxide, which is there, and hydrochloric acid. So they're giving us a balanced chemical equation this time. If they don't give you a balanced chemical equation, my advice would always be to write one. That goes for a lot of different topics across the A level, but yeah, balanced chemical equations are really important. We're then given how many moles of pure zinc oxide we started with, and we're also told the volume and concentration of the hydrochloric acid. So we've been given information about both of the reactants, and I'll come back to that in a second. And then it says calculate the maximum mass of anhydrous zinc chloride that could be obtained from the products of this reaction. So once the reaction's finished, how much of the products would be anhydrous zinc chloride. And again, anhydrous just means without water, so we've got no waters of crystallization in this part of our question. Now, for those of you who are watching this video and are in year 12, you will be used to at GCSE for nearly every single calculation only being given information for one of the reactants, and that would therefore be the information you would use. But what you've probably already noticed in the A-level calculations is that in a number of them you'll be given information about both reactants with a view to having to find which reactant is in excess and which reactant is the limiting reagent, where we cannot compare moles of whatever is in excess because it is in excess. We have more of it than is able to react. So in this case, we know how much zinc oxide we've got in terms of moles. I'm going to have to find the moles of hydrochloric acid. From there, I can compare the moles using the ratio in the equation and see which is in excess, and then whichever one is limiting is the one that I will then use to work out the moles of the zinc chloride, and then from there, the mass of the zinc chloride. So just to help me lay this out, I'm going to copy the equation down. And with calculations, the neater you can lay things out, the more logical you can show you're working out, the easier it's going to be for the examiner. And if you don't get the right answer for the question, they will look back through your working out to give you method marks. So if there's just a load of random numbers written down on the page, it might not be clear what those numbers are referring to. It's going to be harder for them to award you method marks. Whereas for me, with these kind of questions, if I've got my equation, I can write things underneath the relevant species in the equation, like I did in part A, and that keeps everything nice and neat and helps me to know what I'm doing as I go along as well. So I'm going to write 0.0830 moles under the zinc oxide, and then we've been told we've got 100 centimetres cubed, which we have to convert to decimetres cubed, so that's going to be 0.1 decimeters cubed, and then we're given the concentration as 1.20 moles per decimeter cubed. So then we can work out the moles. Moles is concentration times volume, so 0.1 times 1.2 gives me 0.12 moles. Now this isn't the easiest excess and limiting reagent question because the ratio of the reactants isn't 1 to 1, it's 1 to 2. So what we need to consider is, if all of these moles of zinc oxide were to react, we're going to need to have a think about how much HCl would be needed. And because it's not a 1-to-1 ratio, it's not going to be the same value. If you have got a 1-to-1 ratio, the bigger number of moles will be the one that's in excess. That's not necessarily true if it's not a 1-to-1 ratio. So there's two ways that we can go about doing this. We can either do what I just said and take the moles of zinc and think about, if all of those moles of zinc needed to react, how much hydrochloric acid would I need? Well, because it's in the 1-to-2 ratio, I'd need twice as many moles. So if I then do 0.083 times 2, I get 0.166 moles of HCl that would be needed. Now, we don't have 0.166 moles of HCl. We've only got 0.12 moles of HCl. So because that value there is greater than 0.120, that tells us that the zinc oxide is in excess. We don't have enough hydrochloric acid to react with all of the zinc oxide. The other way of doing it is to take the moles of hydrochloric acid and work the other way. So if we take the 0.12 moles of hydrochloric acid and figure out how much zinc we need to have to react away all of the HCl, dividing that by 2 gives me 0.06 moles of zinc oxide that would be needed to react with all of the HCl. We have more than that. We can react all of the HCl and there would be moles of zinc oxide left over. So because that number is smaller than 0.0830, that again tells me that the zinc oxide is in excess. So either way round works the same way. This is important because if we're trying to work out the mass of product, we need to first of all use the moles and the mole ratio to figure out how many moles of this product are going to be made, and we can never use the moles of what's in excess, so we're going to need to use the moles of the HCl. Because that's in a 2-to-1 ratio with the zinc chloride, then the moles of zinc chloride will be 0.06 moles. And then we can use the MR, bless me, that was really bad timing, apologies. We can then use the MR of zinc chloride and the moles to get the mass. So we're going to need 65.4 for the zinc, chlorine is 35.5 and there's 2 of them. So if I add all of that up, I get an MR of 136.4, and then mass is going to be equal to moles times by MR. So the mass of zinc chloride that we could make, 136.4 times 0.06 gives me 8.18. It's 8.184 grams. Based on the numbers in the question, 3 sig fig, 3 sig fig, 3 sig fig, so 8.18 grams. And that would be my answer for the maximum mass of zinc chloride. Again, I'm going to stop the video there for now, keep these a little bit shorter and sweeter than recent videos. If anyone has any questions about that, or a different question that's asking about excess and limiting reagents that you want me to take a look at and help with, as always, please just let me know. Thanks so much for watching, guys, and I hope you have a brilliant day.